Three resistors are connected in parallel and we've been given their values. In part A, we've been asked for the current through each resistor. According to the Ohm's law, the current is equal to the potential difference across the resistor over its resistance. We have the values of resistances across each resistor. What about the voltage across each of them? As they share the same 2 points, the potential difference across each of them will be the same. It will be the same as the potential difference across the battery, which is 9 volts. Let the current flowing through the resistors be I1, I2 and I3. Can you try substituting the values of the resistances to get the current across each resistor? We get the answers as 4.5 amperes, 3 amperes and 1.5 amperes. That finishes part A of the question. And what will be the total current in the circuit? It will be the sum of the individual current across each resistor. It will equal 9 amperes. These are the 2 things we'd learnt about resistors connected in parallel. The potential difference across each resistor is the same, and the total current in the circuit is equal to the sum of the currents across each of the resistors. What was the most important thing we'd learnt though? Yes, it was the overall or equivalent resistance. For resistors connected in parallel, it was given by this formula. When resistors are connected in parallel, the reciprocal of the equivalent resistance is equal to the sum of the reciprocals of the individual resistances. Do you want to try solving for Rp? Substituting the values will give us the value of 1 over Rp as 1 over 2 plus 1 over 3 plus 1 over 6. Do you remember solving fractions? Do you remember the concept of LCM? If not, you should look at our videos based on these concepts. The least common multiple of 2, 3 and 6 is 6, and that can be the common denominator. As the denominators are common, we can add the numerators over the common denominator. As the reciprocal of 1 is 1, we get the value of Rp as 1 ohm. That's the overall resistance of the circuit. What can you tell by looking at it? Yes, the resistance is lower than each of the individual resistances. In a circuit with resistors connected in parallel, the current increases and the equivalent resistance decreases.